All right, welcome back. Let's talk about how to parameterize. And the basic idea is we have to separate what is happening to the x and to the y. So let's take a look at a quick example. We've got a line segment with endpoints -2, 1 and 3, 5. So if I draw a quick sketch, here is my line segment. And let's say that for the sake of argument, we're going to start at t equals 0 at this point. At time 0, we're going to start here. And we want to say it's going to take a second to get to here. Why a second? Well, again, pretty arbitrary, but for the sake of this discussion, we're going to take 1 second to get there. So the question is, what happens to the x value? Well, what we see with the x value is that it increases from 2 to 3 in 1 second, which means it has a growth rate of 5. And it started at -2, so x is equal to 5t plus -2. And my y value, actually change color this time, started at 1 and ended at 5. So the rate of change of my y value was 4 with a starting value of 1, giving me y is equal to 4t plus 1 from 0 to 1. So this is x sub t, this is y sub t. And that's basically it. There's a variety of strategies you can use. Other strategies that I've seen said if we set t equal to 0, then we know that x is equal to -2 plus some rate of change times t, and y is equal to 1 plus some other rate of change times t. And since we want this line to go through 5, 3, then we get 3 is equal to -2 plus a 1, and 5 is equal to 1 plus b 1. Notice that we get b equal to 4, a equal to 5, and if we go back to the equations that I originally wrote, a is 5, b is 4. So different strategies for looking at this. Really what it boils down to is separating out the x and the y values. I think that is sort of the key, separating those x and y values, choosing a time interval, and then saying, okay, what happens to my x value during that time interval? What happens to my y value during that time interval? And writing your equations. We're not going to do a whole lot or spend a whole lot more time. We're just about done with this section. And I may come back with one sort of interesting problem. It's fairly complex. I was working my way through it. It's called the Witch of Agnesi. And there may be one more video where I walk through that, but it would be purely for informative and entertainment purposes. So my students, go ahead and do exercise 23. If I don't come back with that other video, you've had a basic exposure to parameterization. What is it? Why do we do it? A rough idea of how to do some very simple problems. And down the road, as needed, you may run into more. All right. Thanks for watching and have a great day.